Good afternoon, scholars. In today's lesson, we're learning about the mole. And three questions that we want to answer today by going through this lesson. First is, what is a mole? Specifically, what is a mole in chemistry? Also, we want to learn what makes the mole so important. In other words, what are some relationships that the mole has with other aspects of chemistry? And finally, we want to learn how to calculate molar mass, something that's going to be very important in this unit and beyond. The mole, as you learned in a previous video, is a unit used in chemistry that allows chemists to deal more easily with large number of particles. The mole, given by the unit mol, is officially defined as the amount of any substance that contains the same number of particles as there are atoms in 12 grams of pure carbon. Another way to put that is 1 mole of anything is exactly 6.02 times 10 to the 23rd of that thing. Or, if I have 1 mole of roses, I have 6.02 times 10 to the 23rd roses, or a whole bunch of roses. Now, this number, 6.02 times 10 to the 23rd, is a very important number, and it's called Avogadro's number, and is given by the symbol capital N, lowercase a. Now, the reason why the mole is so important in chemistry is because of its relation to many other things. For instance, 1 mole is equal to 6.02 times 10 to the 23rd particles. In addition, 1 mole of any type of gas has a volume of 22.4 liters, provided that gas is at STP, and I'll talk more about what STP means in a moment. Another relationship is that 1 mole is equal to the molar mass in grams for that material. Now, there are certainly more relationships that the mole has in chemistry, but for right now, I want the student to learn and memorize these three. Let's talk about representative particles, or just simply RP. You've studied many of these representative particles throughout the chemistry course this year. For instance, we learned about atoms, the smallest particle of an element that retains all properties of that element. An example of this would be like a copper atom, or possibly a sodium atom. Then we learned about ions. An ion is just simply an atom or a bonded group of atoms that has a positive or negative charge. So anything that has a positive or negative on it is an ion. So possibly a chloride ion or the carbonate ion. Molecules is a neutral particle where 2 or more atoms are covalently bonded. This would be all of your diatomics, O2, Br2, and could also include water. Another representative particle is isotopes. Isotopes are atoms of the same element with different number of neutrons. Remember, isotopes are always written with their mass number. So you could have carbon-12, or you could have carbon-14 as 2 examples of isotopes of carbon. And lastly, remember that the chemical formula of all ionic compounds is known as a formula unit, and it represents the simplest ratio of ions in a crystal lattice. In other words, the pattern that's repeated within the crystal. So, examples of this would be just simply ionic compounds, like magnesium chloride or sodium chloride. Now, what is molar volume? Well, to understand molar volume, imagine there's a balloon. And in this balloon, we are going to fill it with Avogadro's number of oxygen molecules. And these oxygen molecules are going to fill up the balloon. And because gases have pressure, they're going to push against the insides of the balloon. And the balloon is going to expand. Now, how far does the balloon expand? Well, one thing we know, that is, if this gas is at a temperature of 0 degrees Celsius and a pressure of 1 atm, conditions that are collectively known as STP, for standard temperature and pressure, that this balloon is going to expand to a volume of exactly 22.4 liters. Now, because Avogadro's number is exactly 1 mole, this volume of 22.4 liters is known as molar volume, because it is equal to 1 mole. Finally, let's talk about molar mass. To understand molar mass, imagine that we were able to fit a mole of iron atoms in a bag. And say that we wanted to find the mass of that bag. Well, we would put it on a scale. Now, what would that scale read? Well, the value of the scale would be 55.85 grams. And because this is the mass of 1 mole of iron, we can say that iron has a mass of 55.85 grams per mole. Now, something special about this number, 55.85, is its relation to the periodic table. If we look at iron's square on the periodic table, we notice that written there for the average atomic mass is also 55.85. Now in Unit 2, when we were studying about atomic structure, we learned that this 55.85 was the average atomic mass for an iron atom and was measured in AMUs for atomic mass units. Well, now we see that this same 55.85 tells us something else about iron. It also gives us iron's molar mass. So for every element on the periodic table, its average atomic mass is also its molar mass in grams per mole. So now that we know what molar mass is, let's work through some examples of how to calculate it. In this example, it says find the molar mass of oxygen gas. First thing you want to do is make sure that you write down the formula of the thing that you're trying to find the molar mass of. Remember, oxygen is a diatomic molecule, so its formula is O2. Next, we want to list all the different elements that we see in the chemical formula. There's just one element, and that element is oxygen. Next to it, we want to list how many atoms of oxygen are present in the formula. We can see by the subscript that there's only 2. We'll multiply this number by oxygen's molar mass according to the periodic table. And if we look there, we see that the molar mass is 16.00. We're going to multiply 2 and 16 together, and we get 32.00. And of course, this is molar mass, so the unit is grams per mole. This number is the molar mass of the oxygen molecule. In example 2, we are to find the molar mass of dinitrogen pentasulfide. Of course, di means 2, so there's 2 nitrogens, and penta means 5, so there are 5 sulfurs, N2S5. Okay, first we want to list all the different elements that we see in the formula, nitrogen and sulfur. Next, list the number of atoms of each element in the formula, 2 nitrogens, 5 sulfurs. We're going to multiply these numbers by the element's molar mass according to the periodic table. For nitrogen, that is 14.01, and for sulfur, that is 32.07. When we do the multiplication, we get for the mass of nitrogen in the compound as 28.02, and for sulfur 160.35. Now, to get the molar mass of the entire compound, we've got to add up these numbers, and we want to make sure that we adhere to the rules of rounding for addition and subtraction. So when I add this up, I get 188.37 grams per mole. For our final example, we are to find the molar mass of magnesium hydroxide. Formula for magnesium hydroxide is Mg parentheses OH parentheses 2. I'm going to list all the different elements that I see in this compound: magnesium, oxygen, and hydrogen. Next, I want to list the number of atoms of each element in the formula. I see 1 magnesium. There's 1 oxygen inside the parentheses, but the 2 on the outside means that I really have 2 oxygens in this compound. And the same goes for the hydrogen. 1 hydrogen inside the parentheses times 2 means that there's 2 hydrogens. I'm going to multiply these numbers by the element's molar mass from the periodic table. For magnesium, that's 24.31. For oxygen, that is 16.00. And for hydrogen, that's 1.008. Next, I want to multiply the numbers out. I get 24.31 as the molar mass of magnesium. I get 32.00 as the molar mass for oxygen. And I get 2.016 as the molar mass of hydrogen. To get the molar mass of the entire compound, I'm going to add up these values and round, and I get 58.33 grams per mole. For my internet audience, if you have any questions, my contact information is provided. For my students in class, write down any questions that you have to share in class. Thank you for watching and have a great day.